Hi everyone, lesson for today is the characteristic of IBS. Therefore, at the end of this session, students should be able to determine the characteristic of IBS. The characteristics that are going to be discussed in these lessons are based on this research paper presented in the International Conference on Industrialized Building System written by these authors. IBS has 11 characteristics, such as number 1, closed system, number 2, open system, number 3, modular construction, number 4, standardization and tolerances, number 5, mass productions, number 6, specialization, number 7, good organization, number 8, integration, number 9, production facility. Number 10, transportation. And number 11, equipment at site. A closed system can be classified into two categories, namely production based on client's design and production based on precasters design. The first category is designed to meet a spatial requirement of the clients, that is, the spaces required for various functions in the building, as well as the specific architectural design. In this instance, the client's needs are paramount, and the precaster is always forced to produce a specific component for a building. On the other hand, the production based on precasters design include designing and producing a uniform type of building or a group of building variants which can be produced with a common assortment of components. Such buildings include school, parking garage, gas station, low-cost housing, and etc. Nevertheless, these types of building arrangement can be justified economically only when the following circumstances are observed. Number 1. The size of project is large enough to allow for distributions of design and production costs over the extra cost per component incurred due to the specific design. Number 2. The architectural design observes large repetitive element and standardization. In respect to this, a novel prefabrication system can overcome the requirement of many standardized elements by automating the design and production process. Number 3. There is a sufficient demand for a typical type of building such as school so that a mass production can be obtained. And number 4, there is an intensive marketing strategy by precaster to enlighten the clients and designer the potential benefit of the system in terms of economics and non-economic aspect. In view of the limitations inherent in the closed system, an open system, which allows greater flexibility of design and maximum coordination between the designer and precaster, has been proposed. This system is plausible because it allows the precaster to produce a limited number of elements with a predetermined range of products and at the same time maintaining architectural aesthetic value. In spite of many advantages inherent in an open system, its adoption experiences one major setback. For example, joint and connection problems occur when two elements from different systems are fixed together. This is because similar connection technology must be observed in order to achieve greater structural performance. Modular coordination is a coordinated, unified system for dimensioning spaces, components, fittings, and etc. so that all elements fit together without cutting or extending, even when the components and fitting are manufactured by different suppliers. The objective of modular coordination are: number one, to create a basis upon which the variety of types and sizes of building components can be minimized. Through a rationalized method of construction, each component is designed to be interchangeable with other similar ones and hence provide a maximum degree of freedom and choice offered to the designer. This can also be accomplished by adapting a relatively large basic measurement unit or basic module and by limiting the dimension of building component to a recommended preferred sizes. Number 2. To allow for easy adaptation of prefabricated components to any layout and for their interchangeability within the building. This is achieved by defining the location of each component in the building with reference to a common modular grid rather than with a reference to other components. The modular coordination for building component apply the basic length unit or module unit of M equals to 100 cm. This allows the designer to apply this size or its multiple in the productions of building components. Although this concept seems to be easy for adoption, its application involves a great degree of coordination and adjustment in the manufacturing process and the interfacing aspects of components. For accomplishing the requirement of modular coordination, all components need to be standardized for production. Such standardization of space and elements need prescribing tolerances at different construction stages such as manufacture tolerance, setting out tolerances, and erection tolerances so that the combined tolerance obtained on statistical consideration is within the permitted limits. Production resources can be used in the most efficient manner if the output is standardized. The production process, machinery, and workers' training can be best absorbed to the particular characteristics of the product. Mass production. The investment in equipment, human resources, and facilities associated with an industrialization can be justified economically only when large production volume is observed. Such volume provides a distribution of the fixed investment charge over a large number of product units without unduly inflating their ultimate cost. Most of the IBS manufacturers were concerned with the value of returns that could be obtained from the project before the setting up of the IBS precast manufacturing plant, and a rule of the thumb for the profit margin for IBS project is around 10%. Usually, the large IBS manufacturer player will target a minimum production value of 100 million annually, and the new player will target a minimum project value of at least 10 million ringgit annually. The new IBS manufacturer player will choose the mobile manufacturing plant, which requires a lower initial capital, and the average initial cost for the setting up of the plant is about 1 million ringgit. Although the big IBS player have the capacity for setting up a permanent manufacturing plant, the initial capital will cost about 15 million ringgit to 25 million ringgit, and it is 15 to 25 times the cost for setting up a mobile IBS manufacturing plant. Therefore, the type of technology used by the IBS manufacturer will require a high capital investment in order to buy the machineries. For most, the permanent manufacturing plant will have a full cover shaded factory, mold, semi-auto, or full automatic machine running the movement of IBS component, batching concrete plant, permanent crane, boiling steam oven, and acquire high use of electricity. Based on the case, the permanent manufacturing plant has the capability to produce 100,000 meters square per year of concrete with the support of 350 workers. In comparison, the maximum capability in the case of the mobile manufacturing plant is 37,500 meters square per year of concrete, and the manpower required is 25 workers. The comparison case study between the permanent and mobile manufacturing shows that the production capability of the permanent manufacturing plant is almost triple that of the mobile manufacturing plant. The mobile manufacturing plant will have more mobile or permanent crane to erect the IBS component and set up the batching concrete plant. If the size capital for setting up the mobile manufacturing is limited, they can outsource the concrete. Thus, the mobile manufacturer will not be required to focus on the inspections of the concrete, as the concrete is easily cast into the mold. In addition, the mobile manufacturing plant is open air, and the advantage in the tropical weather country is the use of the sun for natural curing, and therefore will be able to save costs. However, Malaysia has heavy rainy seasons, and it would affect the manufacturing process. The creativity of the manufacturer to overcome this matter is by designing portable roofing, which acts to protect the concrete work from the rain. After the concrete has been cast into the mold, the concrete will be covered with canvas and the portable roofing can be moved for the next concrete work. Large production output and standardization of precast elements allow a high degree of labor specialization with the production process. The process can be subdivided into a large number of small homogeneous tasks. In such working conditions, workers are exposed to their work repetitiously with higher productivity level. Good organization. Production requires an efficient and experiences high production volume, specializations of work, and centralization of organizations capable of a high level of planning, organizing, coordination, and control function with respect to production and distributions of the product. Integration. In order to obtain an optimal result, a high degree of coordination must exist between various relevant parties, such as designer, manufacturer, owner, and contractor. This is achieved through an integrated system in which all these functions are performed under a unified authority. Production facility. The initial capital investment for setting up a permanent factory is relatively expensive. Plant, equipment, skilled worker, management resources need to be acquired before production can be commenced. Such huge investment can only be break-even if there is sufficiently demand for the products. On the other hand, a temporary casting yard or factory can be established at the project site in order to minimize the transportation cost. Transportation. It is found that casting of large panel system can reduce labor costs up to 30%. However, these cost savings are partially offset by the transportation costs. The transportation of large panel is also subject to the country's road department requirement. This limitation must be taken into consideration when adapting a prefabrication system. The size and weight of the completed unit may limit the design, and both these aspects need careful consideration at the design stage. Size is perhaps easier to quantify than weight, as there are predictable limits, which have to be recognized. The three obvious dimensions that needed attention are length, width, and height. The length of a volumetric unit should not exceed 12 meters, which is a normal vehicle length. The precast component height should also not exceed the height of more than 4.5 meters when loaded to the trailer. The precast component height could not enter the highway if they exceed the limitation height is range between 4.8 to 5.1 meter. There are further imposition faced when road bridges or tunnels are below this height in some localities and limitation at the site. The significant value for each component of IBS precast concrete should not exceed more than 7 tons to ensure that the crane can be easily erected and transport the material to the site. Most of the experienced manufacturer will send their trailer to survey the road condition and be aware of the circumstances of barriers, especially for the new locations of construction sites. If the trailer need to enter the village road or federal road and are blocked by the trees or electric cable, they need to overcome these matters before delivery of the IBS precast components. The limitation radius of transporting IBS components to the site is around 50 km to 200 km. Meanwhile, the suitable distance from the new potential development area to the fabrication plant should be the distance with a variance from 50 km to 100 km. Apart from the effective distance to transport the IBS components to the site, it is also important to have the precast concrete in partial sizes where they can be plug and play to become large-scale precast concrete. The main reason why the IBS manufacturer choose to produce partial size of precast concrete is to enhance the effectiveness for the erections of the IBS components, easy transportation to the site constructions, and save costs on hiring the appropriate crane. Equipment at site. For the purpose of erecting and assembling precast panel into their position, heavy crane is required, especially for multi-story building. It is therefore important to incorporate this additional cost when adopting a prefabrication system. Before the IBS components are erected, all the IBS components need to have the hook for easy handling and the erections of IBS components. The lifting and installation of IBS component units requires a high degree of skill and high safety planning. The IBS components need to be designed with secure and correctly located lifting points. The lifting point should be matched to the distributions of the weight of the unit to ensure that the item will lifted on a level plane. That's all for the lesson this time, and thank you.